Hi, everyone. Thanks for joining. So my name is Aaron, and I'm the director of the data science program here at Lambda School. And we're all just really excited to have you all with us and to talk a bit about the wide, wonderful world of data science. So just to very briefly introduce, because we have plenty of material to go over the next 2 weeks as well. So besides me, you will also be receiving lectures from not one, but in fact two Ryans. There's Ryan Herr, who
Hi.
that's his face, and and there's Ryan Allred.
Oh, hello, everybody.
So you'll be seeing more of them. There will also be lots of, so we call them PMs for project managers. A lot of what they do is also similar to what a TA would do in an academic setting, if you're familiar with that, a teaching assistant, but we are a little different. We are working with projects in a technical context. So you will see a lot of them are, current, more advanced Lambda students who will be going around sort of helping. I saw somebody raise their hand. Now, this is a new webinar thing. So I'm honestly, if you could just type your question, it's great that you're using that, but I'm not sure what to do aside from say it's somebody raised their hand. So if you have a question, feel free to ask. You can ask in the Zoom chat or you can ask in the Slack channel, and I or somebody else will respond shortly. So with that out of the way, I want to sort of start us off with hopefully a fun poll. So let me go ahead and share my screen. Do you all see my screen okay? And FYI, I can really see the Slack chat much better than the Zoom chat. So if you have a question that you want me to see, use the Slack chat. But let's get started with this. So not expand, just /poll. So you're all here because you want to learn something about data science and machine learning and artificial intelligence and statistics and numbers and computers and etc. So let's think a little bit about, all right, why? You all must have reasons. There is no right or wrong answer, quite obviously, but it's a good thing to think about a little bit. Got a whole range here. So go ahead and keep responding, but as folks respond, I'll go ahead and give a tiny bit of my thoughts. This first category here, this is in some sense the most idealistic, right? The most academic, the most like, oh, research for the sake of research, for understanding the universe. And that's really great. That's where a lot of knowledge comes from. And absolutely, we will be covering tools and techniques related to that. Now, at the same time, that's not our focus, but it is a great thing to do with these techniques and what we will be learning. Now, the second one, I would call that sort of the business angle. It's like, okay, well, it's one thing to try to analyze and understand something. It's another to do it in a way that actually shares it successfully with other people and perhaps, influences decision makers, gives them good information on which to make their decisions. So that is perhaps where, at the moment, the most jobs are. This isn't to say that the others are not worth thinking about. And really, all of these matter, and all of these are things that, depending where you are, you can wear multiple hats as a data person, right? You can do a little bit of all the above. But a lot of what we will be talking about will actually be focusing on category 2 at times, because it's practical, it's useful, and it really, as I said, it's where the jobs are, and you can have a good impact there too. Now, what about 3? Well, 3 is obviously pretty cool too, right? Who doesn't want to build some system that is smart somehow, right? Who doesn't want to build data from Star Trek or something like that? Well, clearly the skills and systems that we will be talking about will touch on a lot of what's required to do these sorts of things. At the same time, building full systems is often a complicated task that involves a lot of people. You might have to work with a front-end engineer to make your nice shiny interface, and a DevOps engineer to make sure that your system doesn't crash, and those sorts of things. So this is absolutely where a lot of the action can be, but it's sort of also this topic that ends up touching a lot of other areas. So anyway, as I said, no right answer, and I just want to give you a little bit of an idea for what sort of things there are out there with data science, since you're all taking this intro course with us, and hopefully we'll continue on to the full course and be in the job market, right? And then you'll be thinking about these things. So now I will talk through a little bit more about data science in general and Lambda School in particular. And then I'll be getting to the actual topic for today. I promise not to spend too long on prologue. The topic for today will be an introduction to Python. So before I transition, any questions of people sort of settled in the Slack and the Zoom? If you've had questions, have you gotten help? Take a breath and drink some water. We're all good? It's important to stay hydrated. All right. So, and feel free to keep typing, by the way. I will absolutely respond. Yeah, all right. So, what do data scientists do? Well, I shared this this news story already in the main Intro to DS channel, so I suggest you check it out. Not right now, but after lecture. It's an interesting read, and it gives another perspective on sort of what I was just talking about. Like, okay, is data science building, these smart systems? Is it understanding data and presenting it? Is it cleaning data? Which is something that you will get to know the joys of that in the near future. We won't be doing that today, but it's not quite like Star Trek. And that's a good thing, because if it was, it wouldn't be a job market for it, right? If the technology was actually as magical as the sort of fictional understanding of it is, then our job would be done. So the technology is still really cool. It's capable of all sorts of amazing things, but it needs a lot of help. And that's what we'll be learning about. So what is data science then? I should have started with the definition. Well, data science is an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from data. Thus speaketh Wikipedia, right? And yeah, this is a decent definition. How do other people define it? Well, if you look around, if you try to ask, okay, what is data science? Besides a kind of flashy job title, well, you find people who make pictures like this, and it's this kind of weird diagram that you have to stare at a while to make sense of. So I'll go ahead and even drop it in the Slack so you can stare at it a little longer if you want. And well, there's like these three areas. There's like the computer science area, there's the math and statistics area, and then there's domains. What's domains? Well, that means actually knowing something about the topic that you're applying the data science to. So if you're working with a pharmaceutical company, say, this would mean knowing something about pharmaceuticals and medicine and maybe biology. And then somehow you have all of these intersections. And this is just one person's opinion, by the way, who made this chart. There's lots of variants out there, but they look kind of like this, where data science is this magic intersection of everything, right? We have the math, we have the computers, we have the domain knowledge, and magic insight comes out. And indeed, there's even more. I put this in here a little tongue-in-cheek. These sorts of illustrations out there to really try to sell data science that are like, oh, it's some, I don't know what they're trying to say here. I guess we're climbing a pyramid of knowledge to the summit of wisdom, something poetic like that, right? Certainly sounds good. And, it is an exciting area. That's why there are so many of you here with us tonight. But a lot of times, what is all this reduced to? Well, it reduces to magic, right? And certainly that is how a lot of this is perceived, even to people who practice data science and machine learning. A lot of it is kind of strange and hard to explain sometimes, and sometimes we just know that something works, but we don't always know why. And that's, again, to me at least, part of why this is an exciting area, because that will change in the coming decades. There will be more research. Those people who voted one up here will be helping us try to even get better true understanding of what our models are doing. But at the same time, it's not all just magic, right? These are systems that we can understand, and these are things we can apply. We can understand the math, right? And we can fit a model to our situation, and we can tell a story with data. That's kind of what I want to motivate everybody towards here overall. Things like, for instance, neural networks are great, and not in the intro course, but in the full course, we will address them at least some. But neural networks are not the most explainable sort of model, and often in a lot of settings, a model that can still get good results but is explainable is really valuable, because exactly, if you're not in the 1 bucket but you're in the 2 bucket, or maybe even the 3 bucket, being able to tell other people what you're doing and why, even the people up here should do that, right? Everybody benefits from having explainable models. That is a great question, and I will defer it entirely for the time being, but I will just say that is exactly, I'd like to say, come to Lambda School, right? That's your first step. Well, I mean, what we work with you, and that's what I'm going to talk about now. So after I've described a little bit about what data science is, what's Lambda School? Well, I'm sure you all already know a little bit because you're here, but what we are is a remote and no money upfront, income share agreement based, or at least that's an option. School, right? And we are more than a boot camp. This is not just like 4 weeks or 2 weeks or something, and then at the end you know how to maybe do a boilerplate and a hello world. This is 30 weeks, right? That's a long time. That's like 7 months, and full time, 40 hours. And I mean, if you have the time, possibly more. Ask our students. But the point is if you multiply that out, that turns out to be roughly as many hours as a traditional full-time student getting an associate degree, like a 2-year degree. So it's not quite as much time studying as a full 4-year undergraduate. It's somewhere in between the associate and the undergraduate in time invested, I think. But it's a lot of time, and it's intense, and it's packed in there, and it's all high touch. It's all like this. So there'll be an instructor like me, talking and interactively lecturing in the morning. There will be project managers helping behind the scenes, because often there's too many of you, but we still want to give you as much help as we can. And then later in the program, to go to your question, we have a whole team called career development, right? And that's their job. Their job is to help you get a job. So because our interests are aligned with yours, we only actually get money when you go out into the world and succeed in the job market. So we want to help you with that. And our full stack web program, which has been running for a while now, is doing fairly well. I'm not sure what our official public numbers are, so I defer to whatever we most recently tweeted. But we are placing students in jobs. The data science program, of course, is a little younger. Our first cohort will be graduating in early October, and then they'll be hitting the job market. So we have high hopes for them, and certainly if you continue on with us to start November 5th, you will then benefit from our experience, and we will do our best to get you into a job. But one part of your question that I like in particular, what kind of projects should I be building? Well, projects. I mean, honestly, it's the kind, sure, it matters some, but something that interests you, something that excites you, as long as it's a project that lets you show off your skills, that is a great way. A lot of jobs that I've gotten because I did projects just for the joy of it and was able to share it and talk about it with people. So that is a great door opener in general. So that was a little about Lambda, but I promised I would get to Python, right? So the one other sort of practical thing I want to share before we move on here then is this is our attendance form. Now this is only for the first day that you have to fill this out. So you should click, and it should be pretty simple. I'll click it here even. You should fill this out now. And you put your name and your email, obviously put your actual ones, and then what course are you starting? You should, and could somebody drop this in the Zoom chat as well, just in case there are people in Zoom who aren't in the Slack? You could drop the Airtable link. So you fill out your name, and then you select the course. It's way here at the bottom, at least for me, DS MBC 0827, Data Science 0827. I'm not sure what the MBC is for. Please fill this out. You only have to do this today because once you do, it'll put you in our system and you'll essentially have a student record, and then you'll be able to fill out the stand-up form. The stand-up form you should fill out at the end of the day. So the schedule is I will keep talking for the next about 40 minutes at this point. And then so Pacific time zone 5 to 6, and then 6 to 7, you'll be working on an assignment related to the Python material. And then 7 to 8, you'll be discussing in small groups guided by PMs. And at the end of that, you should fill out the stand-up form. So again, this first form, go ahead and fill that out now. The second form, fill it out after you've worked on the project and met with the PMs and all that sort of thing, because this is essentially a check-in for how you feel and how you did and that sort of thing. So process stuff, I know, a little boring, but any questions on that? This is how we work with our actual students too. Our PMs can tell you. So we consider ourselves data-driven as a company, not just the data science program. We want to know where you are because that way we can help you. The course ID. So it's, can I copy paste out of this form? Yeah, maybe. It's this one. Any other questions or issues? I'm not sure. If you're not sure, it's okay to leave it blank or put your best guess. I think your Slack ID, yeah, your email might be a good pick. If somebody else knows, feel free to answer. Good question. So our first cohort is in the 20s in terms of number of students. We'll see exactly how big our next cohort will be. We have web cohorts that are around 100 students these days. The initial full stack web cohorts were 20, 30, maybe 40 students. They're up to around 100. So I certainly hope that our data science program grows comparably, but it probably won't get there right away. So somewhere in between 30 and 100. Not a great answer, but hey, I'm kind of a statistician at heart. Okay, that's a good question too, but I'm not going to go into conferences because that's fairly a field. Conferences for people who might not follow it, they're events where academics get free alcohol and talk about important things. They're cool. and they're good for networking. But I don't think that you necessarily need them at this stage. If you have the opportunity, I wouldn't tell you not to go, though. So there are not plans at this time. It's definitely something we want to do, and as we're able to sort of align our plans and resources, but we want to do it right. So we're waiting to make sure that we can really nail it. This is in response to the part-time track question. Any other questions? These are all great questions. Well, yes, you just heard. Well, I was being a little tongue in cheek. Yeah. So if I had to draw a picture like this, I would probably emphasize that all of this, and let me actually take this as an excuse to segue back into the material. How about that? If I had to draw a picture like this, I would probably emphasize, math, statistics, linear algebra. I would emphasize those sorts of fundamental concepts and tools, not real tools, but conceptual tools that we use to understand and to do these things. And to me, if I had to define data science, I would say data science is essentially, in some ways, another somewhat domain-specific subfield of statistics in the grand sense. Other ones that have been around, so biostatisticians are statisticians who apply statistics to biological and medical questions. Econometricians apply it to economics. But the thing is with data science, it's like, oh, we're applying to data. Well, isn't that what statisticians do? No. What we do is we use different actual tools, and that's what we're going to talk about tonight. We use computers, and these computers have, as you all know, gotten amazing and powerful. They're why I'm able to stream millions of bytes at you in real time, so you can see and hear me talking to you. And that is sort of the defining aspect of it. The underlying math is stuff that a lot of it's been around. Neural networks, for instance, they're so hot, I have to mention them again. They've actually been around for a long time. It wasn't like just invented in the past 5 years. What was figured out was that, hey, GPUs let us run really, really big ones. And that changes the results we can get and the domains of problems we can throw at it. And there have been some changes in some research and how we do it, of course, but it's all research is incremental. Even though people like telling stories of brilliant discoveries, most research is a step incremental, building on something that already exists. And that's okay. That's a good thing too. So the one other thing that I want to provide you all before we get into the material, yes, these videos will be uploaded to YouTube later. The last thing I want to provide, and also the last sort of Lambda School plug for the evening, is we have this great thing called the training kit. It's at learn.lambdaschool.com. Pretty easy to remember. And if you go here to data science, you can see our plans. This is actually our planned syllabus for the full course. Starting here. And I'm not going to be talking about this, but you can read about this and ask questions later if you'd like. But what's relevant now is this pre-course section. And if you even click pre-course Intro to Data Science, you get to this page. And I'll even drop this link. If there's one link, I know we throw like a million links at you. This is the canonical link you should know. So if you want to just bookmark or pick, can I star this or pin this? Somebody can pin this, please do so. There we go. If there's one link to know, it's this one. This will have the links to everywhere else. It'll explain about intro courses, so it might answer the questions you have. It'll explain the schedule and process. It will give links to those forms if you still need to fill them out, the first night attendance form, and the daily stand-up form, and it will give links to the notebooks. So unless there are any other questions, I'm going to be going to the notebooks myself now. The notebooks, by the way, yes, we will embed the YouTube links here as well, so you can rewatch this lecture or catch parts you missed. So let's go ahead and do another poll. Or just poll. All right, so a lot of you have, and a lot haven't. That's you're here to learn, and that's good. So we will be using Python 3, but actually about what I'm about to talk about, we will actually not, at least for the first few days here, need you to have local Python really working. And you still should, by the way, and I'll provide resources around that, and that'll be necessary for the full course. But Windows in particular is a little bit funky getting some of these tools set up sometimes. And so we will be using something called Colab, which is a new-ish service from Google. So all you really need is a browser and a Google account. Colab are hosted Python notebooks. So at this point, I ought to define Python notebooks for people. The best way is to perhaps look at one. And I've got to show this one other picture that I meant to show earlier, but now we are starting the real lecture and we're going to learn about our tools. So think of Python as your tool. You are a data scientist. Python, yes, they're basically Jupyter notebooks hosted by Google, but I'll get back to that. Python is your tool, and it is really a dominant language these days in most places of the data science ecosystem. It's in the most job listings. There are other languages out there. You might have heard of R. We will not talk about them in this intro course. If you have to pick one, pick Python. Python is also a solid general purpose programming language, so you can write web applications in it. You can do all sorts of things. It's not a bad thing, but if you have PyCharm locally, if you have Jupyter notebooks running locally, great. That is fine. You can use them. But I want to start with this flow for people. So let's go ahead and get started. This is the lecture notebook. And I'll go ahead and share the link as well. So we will be sharing links of lecture material and the assignments in Colab. And the turn-in flow, because this is a Google-hosted service, you can essentially make your own copies. If you're logged in, you can save a copy. Now, you don't really need to copy the lecture notebook, but the assignment notebook, which I'll give to you later, you should make your own copy. That way you can edit it, finish, do the assignment, and then at the end, you can share it. So I'll show that in about a half hour. For now, let's just look at this. So to give a little bit of context here, really all this is a really dressed up REPL. Does anybody know what REPL means? R-E-P-L? Yep, read, eval, print, loop. And that's why, well, because you tell it to do something, it reads that, it evaluates it, it prints the result, and then it loops. It takes you back to this prompt and lets you do it again if you want. And Python and many other languages have a REPL. Not all languages, but the fun ones, right? And REPLs are great for development, but they're very command line. And in the data world, we like pictures sometimes. We like charts. We also like perhaps nicer documentation, comments. We want to present and share. Remember, again, the second response to the first poll of, part of the point of data is to share insight with others. So a Python notebook is a fancy dressed up REPL where these boxes here really are just code that gets evaluated and then printed the result. And everything else is sort of just nice, I think, markdown flavored text that you can format and do what you want with. So they've become a nearly standard way to present a lot of results in a scientific setting. Now, in a business setting, you might still confuse people if you're like, here's my Jupyter notebook. I don't think that business people are used to looking at this. They could. They're probably more used to spreadsheets. So you'd still could use a notebook for your own exploration of data and figuring out code. And then when you have results at the end, you can put that in some other form to present. The other thing that a notebook isn't is it's not really like a production code. This is not a program that you necessarily run to get output and run as a service. This is more just it's a little looser. It's like, oh, we're just experimenting, we're having fun, we're learning things. That's what a REPL is for, and that's a lot of what data science is for too. So enough chatter, let's learn some Python. I'm going to start from the beginning. I'm sure that some of you are already fairly familiar with Python, or at least aware of Python. But this is an introduction, and I will include tidbits that you might not know about, I think. So what is Python? Well, again, thus speaketh Wikipedia, Python is an interpreted high-level programming language for general-purpose programming. It's multi-paradigm, dynamic, expressive, pragmatic. Okay, it's a lot of words, but in other words, it's a useful way to talk with a computer and get it to do what you want. That's what we get paid for. It's also what software engineers get paid for. It's hard to precisely tell a computer what to do. Computers are not actually magically intelligent. We have to tell them things, and Python is a way to do that. Now, Python is particularly useful in data science because, as I mentioned earlier, a lot of really good packages and systems out there for math and statistics are written in or at least for Python. So it's a great tool. That's what it is. You can also do other things. You can write web applications. If you were in the full stack web program, you could learn about something called Django, which is a web application framework in Python. But we're going to be using more of the quantitative part, the stats. So, well, let's start. What is it? Is it a big calculator? You saw when I used it as a REPL, I was just doing math, and let's do some here. I'll go ahead and even the output's here, but I'll reevaluate this live so you can see that I'm doing this for real. And it's Shift-Enter when you're in a code block to evaluate it. And you can see, yes, Python knows that 1 + 1 = 2. Well, that's great. Here's a slightly fancier one. So I put it in a comment here, but anybody recognize this? Yep. If you've dealt with nasty trig or calculus or polar coordinates or something, you might have vague memories of this. Don't worry, you don't have to know any of that right now. But I just wanted to illustrate that Python is capable of more than 1 + 1. Python can even J, and it's J, not I, but J is how you make an imaginary number. So this is the equivalent of saying E, 2.71828, etc., to the I times pi plus 1 = 0. And that's what we're doing here. We're doing that expression, and then we're extracting the result. So that's cool. Another thing, and the reason I highlight this, all programming languages do this, right? All of them do that. That's really basic. Not all programming languages do this. This is actually kind of special. If you have experience programming, especially with other languages, you might think, well, actually that's just a few imports from the standard library that you have, and I can deal with like complex numbers and stuff. That's pretty cool. And here's another thing that not all programming languages do out of the box. Really big numbers, just sort of arbitrarily large. So at some point you run out of memory, of course, but up to that point, Python actually kind of doesn't care. And so you can just type in enormous numbers, or what is this called? What am I doing on the second line here? Yep. Scientific notation. And exactly, this is something that you should try to be familiar with, be comfortable with, because you will see it in various contexts with data and computation. What it really means is this number, so I put 23 times 10 to this power. So it's like 23 followed by 79 zeros, right? Is that right? Now note that when Python evaluates it, it changes it a little bit, because the standard with scientific notation, this is already a power of 10. 23 is 2.3 times 10. So we just reduce it to be 2.3 e to the 80, or e plus 80. So it's a much more compact, convenient way to represent really big numbers. Of course, you lose some of the detail. You could add that back in if you wanted. And another thing about numbers is there's kind of two types of numbers. There's floats and there's ints. And this is something that Python does a pretty good job at kind of assuming the right thing most of the time, but you might still run into situations where you get these mixed up. So it's good to know what they are and to try to identify when you need what. So, I'll just start. Which one of these is a float? Since I don't even actually say here in the notebook. I should perhaps add a comment, right? Yes, this is our float. And this is our int. Now, float is short for floating point. And it has to do with reasons for how this is represented in memory, but you can think of it as something with a decimal point, right? And it's when you want that sort of fractional decimal detail. Ints are always, or integers, that really is integer, like the math. And in math, integers are these numbers that are whole numbers. They include 0, though, and they include the negative numbers. So any just number, that's an integer. And the reason this matters is because in some programming languages, when you divide two integers, you always get an integer. But in Python 3, I should say, this is one of the differences between Python 3 and Python 2. In Python 3, if you divide two integers and they don't divide evenly, you get a float. So that's a common gotcha if you were expecting it to be an integer, but actually, a lot of the times you're expecting the float, and that's why Python did that. It's a little bit more natural for math and data. So yeah, 3 divided by 2 is 1.5. That seems right. Now, if you want, there's this operator here. This operator, I would call it like integer divide. And if you divide two integers with it, then the result is guaranteed to be an integer as well. So if it was supposed to be a float, as it were, it actually, exactly, it truncates. It does not round, it truncates. And in general, that's what integer division does. And so yes, truncate or floor means that, if we changed this, for instance, to be 5 divided by 3, that should still round down. Am I doing this right? Yeah. So if we look at 5 divided by 3, that's 1.666, etc. But 5 integer divided by 3 is truncated down to 1. So that's a good point as well. So numbers, math. It might seem boring or simple, but this is a lot of what we care about. But wait, there's more. Yes, exactly, drops this part. Python isn't just for numbers. Python lets you process text. So anybody know what RE stands for? Regular expression. And it's this complicated kind of weird language in its own right that I won't talk about right now. It owes its existence to another language called Perl. But these days, pretty much all computer languages have regular expression support, including Python, of course. And it's just because it's this really handy way to match and replace patterns in text. And even though regular expressions can be really crazy, just directly matching a literal string is actually fairly intuitive. If we have meet me at dawn and we want to replace the word dawn with dusk, we can do that. Yes, if you have a deep understanding of regular expressions, I don't know if anybody's a deep understanding. If you have a lot of practice with regular expressions, it is very useful, especially if you're interested in things like scraping websites, trying to get data. But what else can you do with Python? Well, you can draw pictures. And this is also showing off the power of notebooks, because this would not work the same if I tried it back in my command line REPL that I showed you a while ago. But here, in the comforting world of Colab, we can just draw a picture. And this is using one of those really important math stats libraries I told you all about earlier, called Matplotlib. You'll be seeing more of this. And it's also using NumPy, which is another library that's really important that you'll be seeing more of, that is essentially about representing, well, numbers, but specifically things like vectors and matrices. So, what's happening here? Well, essentially, we're making a range of numbers, we're calculating sign based on those numbers, and then we're just plotting them. And actually, all this stuff down here is just nice, like it's bookkeeping to sort of label the axes and such. But the plot itself is really just happening right here. And there's a lot of pretty plots. You'll have the opportunity later to look up the gallery of plots that you can do with Matplotlib, and it's pretty impressive. So again, for people in that 2 bucket, this is really important as a way to show what you've figured out with the math that you did earlier. But wait, there's more. I'll wait a second as people type. Do I shorten the names just for a style choice? Yeah, it does look like it's excluding, well, that might be on purpose. Often in Python, ranges always include the beginning but exclude the very last thing. So that might actually be on purpose. Now, as far as the names, yes, this is a very standard way. Yeah, I understood. This, you don't have to. I mean, we could import NumPy as magic crazy thing. And, a module by any other name is just a memory address for the computer. But it's very standard to pick these sorts of descriptive short names. And I've noticed, especially common in the data science community, software engineers working on like Django projects don't necessarily do as much aliasing as this, in my experience. But when you do it, just try to be descriptive. And it's because you're going to be typing this a million times, right? Oh, np.arange, np.sign. You're just making your life easier, especially while you're experimenting. You don't just paste working code. You have to try things. And anyway. We will absolutely talk more about code style. It's one of my favorite topics, but it's also, I have to admit, not the most important topic on the first day. So what else can we do with Python? Well, even more. It slices, it dices, it grabs data from the internet. And this is readable, right? I haven't actually really taught you anything about Python, but you can read this, right? Okay, from URL lib, that's a little bit of a weird name, but library of URLs, import request, and request opens some URL, example.org, which if you don't know is a standard website, the example domain, and then just read lines. Yes, this is, if you wanted to actually scrape and process this, there's a lovely library called Beautiful Soup. It, among other things, has a lot of regular expression power. But just to prove how simple it is to grab a website and spit out its text, it's 3 lines and just using the standard library. So all the imports I've done so far you get for free with Python. You don't have to install anything besides Python to be able to, well, that's not true. Okay, except for this example. Matplotlib and NumPy need to be installed. But all the other examples are things built into Python. So hopefully you're sold a little bit on the power of Python. Now, how does Python actually work? Well, Python is actually kind of a small language. And by that, I mean that it doesn't have as many sorts of types or constructs as, yeah, I'll get to that, as other languages. JavaScript is a really big language. They keep on adding features to it every year. Python is smaller, partially because for most of its history, it was led by one person, a dictator, as it were. So what are the types that are available? Well, there's a few more types than this these days, but these are the core ones. These are the core literal values you can have. A literal value is just some singular thing that can be represented in memory. And you've already seen most of these in the examples we already ran. You can have a string. You can prefix this string, for instance, to be bytes. So these are escape codes. I won't go into details, but refer to the official documentation if you're curious. You probably won't have to use bytes too often. Yes, you can also prefix this with R to specify that something is a regular expression, but essentially all of these are sequences of bytes. That's what a string is too. And there are just different ways to encode or specify what sort of string it is. There's integers, you saw that. There's floats, you saw that. There's complex, you actually saw that, if you remember the Euler example. And then there's Boolean, true and of course false. That's what a Boolean is, and as you'll see, it's pretty important for deciding the flow of a program. And we can sort of see some of these examples. So yeah, I found these bytes, which look crazy. If you decode them into Unicode, which is sort of the most standard way to have strings, this is actually, is that the euro sign? Some currency symbol, right? And similarly, literals have ways to cast type. So you can take a float and you can cast it to be an int, and cast just means force it to change its type. And assuming that that's valid, you'll get the result, which is a truncated float. Now, note that this isn't going to work so well for like this, right? Invalid literal for int 10 with base 10 cat. So Python doesn't know how to change cat into an integer, right? Unsurprising, I don't know either. So these things, again, they're not magic, but they are functions and they do useful things. And this is it. These are the core base literal values that you should know about. So as I said, small language. Well, what's next? The thing that makes computers nice isn't really literals. It isn't just single values like this. It's data structures. Computers can have lots of things in them at once, right? They don't just have the word cat, they have the entire dictionary. And how do you represent more than one thing at a time? Well, in something called a data structure. And again, this is just a taste. Refer to the official documentation for more. But the core data structures, again, there's really only a few of them. There's lists, and a list is just ordered values. And note in the example here, I purposefully put, what did I put in this list? Yes. Some programming languages do not like this. And literal values is also a correct answer, by the way. I'm not sure why Slack is trying to advertise, so ignore that. So Python lets you have different types in a list and in most of its data structures. Just an important thing to know. If you don't come from a programming background, you might think, all right, big deal. Yeah, it's natural, you would think, to be able to do this. But a lot of programming languages don't let you do this, and they have good reasons too. But Python lets you do this. You can also have a tuple. The difference between a list and a tuple, the list has these guys. Tuple has parentheses, right? And the difference as far as what it means to you, well, it's still an ordered thing, but it's immutable. And that's a complicated enough word that I won't get into the full technique, the full meaning of it right now, but I will say that what it basically means for you is lists are good for long things that you might have to change a lot, and tuples are good for short things that are just like a few settings or parameters that you're not going to change, and you just want to put them together somewhere. Then there's sets. Sets, anybody know what's special about sets? Even add another code block so I can type in things. Yep, no dupes. So if I were to make a set like this and evaluate it, what would I actually see? I should make this bigger too. Sorry about that. Go ahead and do it. Yeah. That's probably what you were typing. Sorry for jumping the gun. Sets are collections of distinct values or unique values. However, let's ask another question. What will this print? If I ask, hey, is the set 217 equal to, that's what double equals does, 17, 2. Is it false? What's happening? So you would have been right if this was a list. Now lists do not remove duplicates, of course, but these are different lists. Order matters for lists and tuples, by the way. Order does not matter for sets. That's the key thing to know about sets. They're distinct and order doesn't matter. And what sets are good at, by the way, is membership. So if lists are good at just like long streams of things, and pretty soon you'll be putting those into actually NumPy arrays. But you can think of NumPy arrays as dressed up lists. And if tuples are these like, you know, smaller, more mysterious things for the time being, that's okay. Sets are, you know, you could have something like every state that was visited is some sort of set. And then you could ask like, is Ohio in state visited? And this would return true or false. In fact, this is valid code. That's what I love about Python. You can just type stuff and it actually works. This will return false because right now this is an empty set. But if we actually put Ohio in it, this would return true. Yeah, it's very exactly. It's the same as sets in mathematics, so it's a good area to study. You can do this, by the way, with the other data structures. You can use the in operator, but sets are most efficient. So if you're doing a lot of it, use a set. And then last, but definitely not least, the sort of grand workhorse of data structures, Python dictionaries. Python dictionaries are kind of intuitive. They're basically, they're hash tables, if you want to think about it as a computer scientist. But if that doesn't ring any bells for you, that's fine. Just think of it as key value pairs. These are the keys, and this is the value. So we're saying this is a structure where if we feed it A, it returns awesome. And if we feed it B, it returns best. You might wonder, well, why is something like that useful? Well, imagine you had a data structure for your users and you feed it a user ID and it returns a list of movies they like or something. That might be a pretty useful data structure. And you could build a movie recommender system or something like that. So it's a very useful and very efficient system. The lookups are very, very fast. Essentially, the keys are a set. Now, any guesses why the keys are a set? Exactly. You can't have two, like if you look up the word in a dictionary, it's got to have one meaning. Well, I guess technically dictionaries have multiple meanings, but one entry for that word. You can't look up some word and have it have two separate entries in a dictionary. It needs to just be in there once. And then the last thing, and we're already haven't quite run on full schedule here, but I'll keep moving as best I can. Very few people talk about Python lists without saying how cool list comprehensions are. So let's run this whole thing. What is a list comprehension? Well, it's basically a kind of backwards for loop that automatically returns a list. But if you just read it, it does. These are all just English words: print, word, for, word, in, and then there's a string. List comprehensions are cool. Dot split. So okay, you have to read it backwards to really understand it, but we're saying take this string, split it up, and then for each word in that string, just put that word in the list, right? You could do things to it here if you wanted. You could add, for some reason, you could add the word foo to every single thing in the list. So you're not restricted to just reusing it directly. But it's a useful structure. A little more on lists, and I'm going to keep moving a little faster now in the interest of time, but this will be recorded, so you can, of course, review it. List slicing. This is another thing that is, if not unique, at least pretty strong for, pretty strongly representative of Python. I will answer that question because it's a good one. Keys have to be hashable, which is to say the key has to be something that is immutable. If your key was mutable, that would be a problem because the key could change and then it could get disconnected from the value. So you can't use lists as keys, but you can use tuples. So whenever you want a dictionary that has a data structure itself for the key, think about tuples. And all literal values work. Like all literal values can be both keys and values. And data structures can be values. Yeah, it is very cool. So Python list slicing, you might, if this is the first time you've seen this, you're going to have to review it a few times for it to sink in because it's elegant but minimal. But once you get used to it, you will wonder why you should ever use anything other than Python. So it's very normal to do things like this. If we just have our list here of some letters, you pull out the zeroth thing. Computer science starts from 0. So the zeroth thing is the first thing to us. And what is that? Well, that is the letter A. Now let's say you want to pull out the last thing. In a lot of languages, if this was JavaScript, it would be something like print letters of letters.length or something like that, right? -1, I guess, because we're 0 indexed. And that's kind of ugly. And you can do this in Python. You can say letters of length of letters -1. And this will get you the last thing in the list, the very end thing, but step back 1 because we started from 0. But for short, you can just say -1. And in general, negative indices just index from the back. So -2 would be 2 from the back. -3 would be here. So it's an easy way to get at the last thing. You get at the first thing, you can get the last thing. So positive and negative indexing. It's very cool. And slicing. If you put a colon in here, this now becomes a slice and it returns not a single element, but another list. And well, what list? If you put a number here, it returns up to that many things. So the first 3 things. If you put a negative number on the other side of it, it returns the last 3 things. That's really cool. If you put a positive number on the left-hand side, then it skips that many things. So it starts from 3 and returns everything else to the end. And if you put a negative number on the right-hand side, as again, review this, make flashcards maybe, but it is really cool. A negative number on the right-hand side means that you basically drop the last 3 things. You go up to the last 3. And you can, of course, print everything except the last 3, yeah. And this isn't even my final form. You can combine them. The general meaning of a slice is from start to end, and you can actually even add another value here, interval. By default, interval is 1. Just go 1 by 1. But for instance, you could say, okay, let's start from number 1 and go to number 5 by intervals of 2. Okay, we start from number 1. Remember, that's B, because A is 0. And we're going to go by intervals of 2. So we go from B to D, and we stop when we get to 5. Well, we got to 5. 5 is E. So that just returns a list of B and D. So you can skip things. And you can even do cool things like this, where if you omit the start and the end, so implicitly it's the whole list, but you go by a negative interval, guess what? You just reverse the list. So reversing a list in Python, very, very easy. All right, how much? There's still a lot here. I'm going to run another 10 minutes. If there are any grand objections for that, or you had something to do right now, this will be recorded. I will get through the rest of this in 10 minutes and then drop the assignment. Sorry for running late, but there was a lot of prologue at the beginning. There won't be so much prologue in other days. We will just be jumping right into material and hopefully hit our time target better. Hopefully that's okay with you. If you have issues, ask for help. All right, so let's see here. We've talked about literals, the values. We've talked about data structures, putting bunches of values together. Now, truth, falsity, and comparison. So, well, we know what Booleans are, and we can compare them with double equals. Now, that said, there's also this word is, and it's kind of important to know. This is one of the things that maybe you out there with Python experience, this might be new to you too, the difference between double equals and is. So in general, when you compare two things, Python will try to see if they're the same and then return true or false, depending on what you're asking. You can also, of course, do not equals. I guess I should have included that as an example, right? So for instance, false does not equal false will actually be false because false equals false. Now, if we look at this, print true is true, that returns true. But that's because true is a single object. There's just one object in Python to represent true. If we make two separate strings, these strings both look identical, Lambda School rocks. But if we compare them with double equals, we get that. So I know it's a little bit hard to see here, but this line corresponds to this. This is true. True. They're the same string. False. They live in different places in memory. So what's going on here? Equals is double equals and not equals is a value-based comparison. So it actually looks at the values and says, yes, these values line up. These bytes are the same as these bytes, right? Is doesn't actually compare the values, but instead just compares the memory address. Now, if the memory address is the same, then the values are the same. Memory address is just a way of saying where it lives in your computer's memory. So if you have two different things that point to the same part of computer memory, they will be the same. But in this case, we don't, because we declared our string twice. It's two separate strings. And you can tell that by this little magic built-in function in Python called ID. And what it gives you, this number here, actually represents where in computer memory this string is living. And you can see, even though it's the same content as string 2, this number is a little different. And so they're different copies, and so they're not the same thing to is. Any questions on that? Speeding up a little, I know. Other comparisons work as you'd more or less expect, based on math or other programming languages. That's a good question. So let's try it. The best thing to do when you have a question like that, let's do our own like 3 and 4. S equals, this is a good question. S4 equals S3. And let's print whether they, opinions. Do people think this will, sorry, type this out. This will be true, false when I run this? Pretty even split. Well, I'll go ahead and, true, it is true. When you assign like this, you're giving yourself another way to refer to it. You're giving another name to it for you, another variable name, but the computer doesn't actually copy this. You could call this like a shallow copy or a reference, if you will. It just refers to the same thing as string 3 did. And by the way, lists work the same way. If you have list 1 equals 1, 2, 3, and list 2 equals list 1, and then we try to change something about list 1. We reassign the 0th thing to be -10. And then we look at list 2. We changed list 2. Because list 1 was the actual list, and list 2 is just pointing to list 1. So when we change list 1, we also change list 2. It's going to vary from type to type and structure to structure. Lists are like, most data structures will be kind of like this, though, yes. Any other questions? All right, so as I was saying, comparisons kind of work as you'd think. You can do greater, less than, greater or equal. You can even compare ints and floats. Some languages would not let you do this. Python is okay with it. What you can't do is this. What am I trying to do here? That's why there's this type error. And Colab helpfully says, maybe you should search Stack Overflow. I hear there are smart people there. Yep, this is an imaginary number, and this statement doesn't really make much sense. You'd have to take their magnitude or something. Exactly. And this would also, by the way, there are other type errors you could do here. You could compare, I don't know, numbers to lists or something, and Python will also freak out at you. Well, except it didn't even get to that, so we have to comment this out. Yeah, but it doesn't like that either. Suppose I should have started by saying comments. Make comments in your Python code, please. You see that I do it all the time. There are these things that start with a hash. Comments make code more readable. Good variable names help too. But when we ask you to do an assignment, we do care about the readability of your code. So let's learn sort of like the pieces, the elemental bits of Python. Try in a few more minutes to cover the rest of the language. So let's see here. Iteration. So iteration is what you know as looping, perhaps. And indeed, you can do for loops where you just have a list with things. And by the way, Python supports fancy Unicode stuff. That's why I threw that in there. And then it's pretty intuitive. You can just loop over for each thing in a list or other iterable data structure with multiple things. You can print it. And indeed, what do you get? You get all the steps printed out. And eventually you launch a rocket. You can also use range. Range is a lot like slice, like list slicing. Takes a start, an end, and a step. So we're starting from the number 10, we're going to the number 0, and we're stepping by -1. It sounds a lot like a countdown. So we print these numbers cast into a string. Good suggestion, Joanne, by the way. You can compare strings. So we change it into a string. That way we can add ... and print it. We get our countdown. So loops, right? Because the whole point of a computer is you don't want to write everything that it needs to do. You want to write a loop so it can go over that whole structure of the entire dictionary or every tweet ever or whatever and do something smart with it. So simple loops with for. You can also do comprehensions, which I sort of already showed before. So range, you already saw, if you just give it one value instead of the full start, end, step, then it just assumes that it's starting from 0 and going up to that number. So range will just say, hey, let's go from 0 to 10. You can cast it to a list. Again, list also has this cast function, in which case you see all the actual numbers. And you can do fun things in list comprehensions. String cast is required in this case because we're adding ... and it would give a type error if we didn't cast this to a string, because it'd be like, I don't know how to add numbers to strings. If we just printed the I itself, we wouldn't need to cast it, because print actually can handle an integer on its own. So what is this here? Well, this is essentially this line, this list comprehension, is just a more compressed version of something like for I in range 10, like we'd have to have our result list. And for I in range 10, and then there's an operation append to put something on the end of a list. I times 2. And if we do this, we should see the same list. So, but this is kind of a lot of lines of code for something that's not too complicated. So it's nice to do it in a single line like this. Python tries to be concise when it is clear to do so. Any questions on this? All right, I'm going to speed up for real. Thank you all for your patience. Conditionals, this one's pretty intuitive. You have a Boolean, in this case it's hard-coded, and then you check if, and if this Boolean statement evaluates to true, do this branch of code, otherwise do this branch of code. Might seem simple, but it turns out that when you combine conditionals and loops, you get basically arbitrarily complicated systems. That's the magic of computers. Now, there's a few ways to do it, not too many, but this is another cute approach. You can have a while statement instead of a for statement, and while actually takes just a Boolean condition. As long as it's true, it will evaluate this. So essentially, this is like a for loop for three times, but it's counting it down a little bit differently and eating the cookies. In general, I would say you shouldn't use while loops most of the time. For loops are usually better and a little safer because while loops you can accidentally get infinite loops. But you should know what they are. What else can you do? Well, strings are actually iterables. Strings are kind of like arrays. Remember, they're sequences of bytes. So you can ask the length of a string, and you can use else if. So it's not just if and else, but you can check multiple conditions. If this condition, else if this condition, else, and this is the catch-all statement that will happen if none of the conditions are true. So similar to structures in other languages, but elif is the Python word for it. And yeah, you can combine it. So this one I will not step through in detail, but if you understand this, you can get through a common screening interview question for software engineer positions called FizzBuzz. All FizzBuzz is about, really, is understanding loops and conditionals, looping over a range of numbers, checking some conditions, and printing different things based on those conditions. And specifically, we want to print the numbers from 1 to 100, but when it's a multiple of 3, we print fizz. When it's a multiple of 5, we print buzz. And if it's a multiple of both 3 and 5, we print FizzBuzz. Otherwise, we print the number. There you go. It's just loops and conditions, and you get this. And this is the sort of code that you commonly have to write to some extent. Now, another thing just to leave here, it's possible to be too clever. You can do this whole thing in a list comprehension. This first list comprehension I wrote, and I find it a little more readable, and it prints the numbers of the indices where FizzBuzz happens. But you can do the entire thing. You can actually make this complex little expression that gives you all the FizzBuzz in a list comprehension, but it's doing magic. Be careful with code like this. You might think you're being clever, but really you're just making it harder than it has to be sometimes and harder for other people to read. All right, keeping going. There's a light at the end of the tunnel here. That said, it's still a little far away. So I might skip ahead a little bit here. What else can you do with control flow? Well, you can loop, you can do conditions, you can break. Break exits a loop. Now, it only exits the loop that you're in. It doesn't exit the entire loop if you're in a nested loop. You can have an else in a loop, which might seem strange, but what it means is if you break out and you're done with this, you evaluate the else condition. Again, I'll refer you to the documentation link here if you're curious for details. But the point is, control flow can be a little more complicated. What else can we do here? Continue. What continue does is it doesn't stop the loop entirely. It just skips the rest of that iteration. So if we have our poem here, "'Twas brillig and the slithy toves did gyre and gimble in the wabe," and we want to get that poem without the letter E, we could loop over every letter in the poem. I'm not saying this is the best way to do it, but we could loop over every letter, and if that letter is E, we continue. That is to say, we go to the next letter. We continue to the next iteration. But If that wasn't the case, then we end up evaluating this line, where we add the letter to our poem without E. And at the end, we get "'twas brillig, and the slithy tovs did," etc. So it skipped all the letter E's. It didn't add them to our string here. And yes, you can add things to strings. Plus is concatenation for strings. One other thing that's useful in Python: break, continue, and pass. Pass just literally doesn't do anything. Why is that useful? Well, because Python has opinions about white space. If you didn't have this statement, like let's say you also have some other code here, this runs, and this is fine. But if we didn't have this line here, I'll just even delete it. Now we get an indentation error. It wanted there to be something here. It doesn't care that it's doing nothing, but it needs something to be here because Python doesn't have all those curly braces that languages like C and JavaScript have. So Python knows where it is by having things that are indented. So pass is essentially a filler, and then you can leave a little comment for yourself saying, I should come back to this. All right, this is the last real topic. So thank you all for your patience. Are people okay sticking around for like 5 minutes more? Promise we won't run late tomorrow. Hopefully. All right. I say, Python's this tiny language. I can cover it in an hour, no problem. All right, turns out I need a tiny bit more than an hour. So the last big thing you should know about Python for now, functions. Because we really have covered a lot of ground. This is it. This is Python. These are the types. These are the structures. This is how you do control flow, loops and conditionals. This is the language. But you don't want to always, find where I am. You don't want to always write everything just line by line and never reuse your code. You want to define functions. And then these functions you can give a nice little name to, and you can use them. How does that work? Def is the keyword, the name, parentheses, and then the arguments, the input to the function, and you can have multiple separated by commas, and they can even have default values if you want. So they will be this if they are not specified. If a value does not have a default value, then it has to be specified when the function is called. Otherwise, there'll be an error. But we take that, and in this case, most functions have a return statement where they do some logic. In this case, we just add 1 to x and return it. Increment. So whatever x is, we give it to increment, we get back x plus 1. That's a nice function, even the sort of math function your mathematicians would approve. And how does it work? Well, we can make some numbers. Let's put them in a list. And let's do a friendly list comprehension and increment each of those numbers. So we're going to loop over for number in numbers, increment that number, put that result back in a list, right? And we can even do this twice. In this case, we're looping, the structure of the list comprehension is the same, but we increment number, and then whatever we get back from that increment call, we also increment, and then that's what we keep. And so we get this incremented twice. Now, maybe a better function would be something like increment by y, which takes an x and a y, and then we could return x plus y. At this point, we're reinventing addition, though, so I'll stop for now. The point is, these are useful. That might seem simple, but you can have far more than one line of code here, of course, and you can reuse then this function just by calling it by the name. So this is the example I sort of have here. I called it number adder, takes x, takes y, has a default for y. So if we call it with just a single number, then 10 plus 5, the default value is 15. But we can override the 5 and say, no, we want y to be 3, and then it adds 10 plus 3 gives us 13. So, basic function. You might have heard of these things called lambdas, though. We are, after all, lambda school. A lambda is a short function. They might also be called anonymous functions because they don't have a name. And the appropriate use of a lambda is when you're doing something so short that you're only using it once and you just want to sort of throw it in line. So here we have some more numbers, and we're going to map, which means apply a function to everything in the iterable. And we're going to map this function that takes a number and returns it times 2. And then technically map doesn't return a list. It returns a map object, but it's basically a list. And if you cast this result to be a list and print it out, you get these numbers doubled. 5 times 2 is 10, 7 times 2 is 14, etc. Map and lambda are cool. There are a place for them, but actually, in this case in particular, and a lot of other cases really, sometimes a simple list comprehension is best. This would be the most, I think, clear way to write the same logic. We could just say, hey, why is that a lambda? Just do it right here as a list comprehension. All we're doing is multiplying the number times 2. Now, if you're into functional programming and if you use a more opinionated language than Python, you might have more call for lambdas. But lambdas are increasingly something that are not used as much in Python. But they exist, so you should know. All right, keep it moving. I'm not going to talk about this too much. Functions are first-class citizens. What does that mean? It means that they're actually things. They're objects. Just like all those literal values, I won't scroll all the way up. Just like all those literal values and data structures, a function is an actual thing. And the reason that matters is you can have a function that takes a function and return functions. We already kind of did that. Map is a function, and it took a function, a lambda, but that's a function. But you can even make your own function. So this is kind of a cute example. It's a function announcer maker. It takes a function. It defines its own function inside of it, where it prints the name of the function that you gave it, and then it actually runs that function. And then it returns this function announcer. So we already had that increment function from before. If we make an increment announcer with function announcer maker, then, and we call it on 5, it still does what it should. It increments the number, right? So 5 plus 1 is 6. Great. But it also prints the name of the function now running increment. So simple example, but powerful concept. Functions are really things in Python. They're first class. Something to be aware of, and you'll appreciate it more as you learn more of the language. And then the last thing before we get to the homework, gotchas. I won't step through all these. I kind of already showed some of them. Lists are these shallow copies by default, right? So if you make a list and you make another list and you change something, it changes them both if they were just an equals. How do you fix that? Well, you want to actually copy the list. There's a few ways to do it. I discuss it here. You can slice through the whole list, and that makes an actual copy. You can import deep copy from the standard library, and that makes an actual copy. But the point is, this is a pretty common gotcha, really. You need to know when you want a different copy of something sometimes. And this is another sort of strange example. You just saw the power of default arguments, but you generally don't want to put data structures as default arguments. You might think, oh, but that would be great, right? I have an empty data structure. I'm going to have a hash maker, and it starts a hash, and it populates it. Well, the problem is, you call it once, you give it, okay, A is my key, 1 is my value, I want to store that in my hash, and then I call it again, it actually remembered the previous hash. It didn't reset this to an empty hash. So because of the way this is actually referred to in memory, it remembers. Setting this to an empty value doesn't actually reset it each time that the function is called. So another common gotcha, there are ways around it. Basically, you can just set it to none. Instead, none is a special Python object. I should have mentioned it with the literals, I guess. It's a special thing, and it really just means nothing. More nothing than 0 even. It's just none. And then you check, okay, assign the hash to either be the hash if it was passed in or an empty list. But by doing it inside the function and not inside the signature, it will actually change it each time. If the last 2 or 3 minutes of what I said was too fast for you, I apologize. It's okay. These gotchas are things that I learned the hard way, and you will probably have to learn the hard way too. I just wanted to give you a heads up. So maybe later on with your Python career, if you're encountering something that makes you go, is this that thing that he told me about? You can look it up and try to figure it out. So that's it. Well, you survived this. Sorry again for running late. What else is there? All sorts of things. I'm not going to talk about them anymore. But hey, it's Python, it's magic, it's beautiful, it's simple, hopefully. And with that, what's next? The assignment notebook. So just to make this a little clearer, how does this work? This is the way a lot of our assignments, I think all of our intro course will work. You come to this notebook, you make a copy, so save your own copy in Drive. I won't click it because this is already mine. And then you come down and you read, you read the problems and you try to answer them by writing some code, right? How does that look? Well, let's give an example question here, and it's at the bottom of this notebook for reference too. So here's a question. Okay, George has the same number of male classmates as female classmates. His classmates, blah, blah, blah. How many students are in the class? Use loops to check for combinations. And then I wrote an answer, and it's not necessarily, as I said, this is not the minimal answer, but it is clear with good variable names and comments. We want to see this, and hopefully this is also helpful to you. But you can see it does a bunch of logic, it loops, it does some arithmetic, it uses some control flow things like continue and break. And then at the end, it finds the answer and it prints it out. So this is what you want to be doing. At this point, especially because we ran late, I wouldn't expect many people to finish this notebook tonight, but try to make as much progress as you can. And then a bit after 7 o'clock, the PMs will be available to start meeting in small groups and talk about this in more detail.
Hey, Aaron.
Any questions? Yes?
Aaron, do you want to say that we'll do the small group starting at
7:30 maybe?
Yeah.
Yeah. Small groups 7:30.
Yeah.
So you have at least an hour to look at this on your own. It's still okay if you don't get through all of it. But this is the pre-course work. This and the continuing assignments will give you through the intro course. And then what you do, as instructed here, after you make your copy and fill it out, you can share. And you can share it with ML submissions. Oh, and even autocomplete. Well, maybe just for me. Might not autocomplete for you, but ML submissions at lambdaschool.com. And you want to share it with that email address. That way we know you did it. Or is there also the form that we have them fill out? Is there a link for the homework there?
There is. So on the form, there's it says a URL for your submission for today's project, so they can just share a link there.
Okay, then just share a link. So don't worry about, I'll change the description. Make sure that people with the link can see it. You might have to change the permissions. So, because it might be, it might be something like this, which just broke it if anybody was looking at it. So you want to change it to say anybody with the link can view. And then share this URL in the form, the stand-up form at the end. Exactly.
I'll pass out the stand-up form link at the end of the, or actually we'll do it at the beginning of the meetings in an hour so that you can fill that out.
Yep, so I'm changing the note here. Make the URL for the notebook viewable and submit with a stand-up form. All right. Thank you, and thank you all for your patience with this long-running lecture. The video will be up shortly. Get as much done as you can in an hour so you benefit from the group session later. But in terms of hard due, this needs to be done, I think, like the Thursday before the next cohort is when you need to have all the pre-course work done, I believe is the deadline. I will double check that. So the next cohort starts November 5th. So whatever the Thursday before that is when you would need to have this and all the other notebooks done. All right. Thank you, everybody. This has been a lot of fun.